This production is brought to you by the University of Edinburgh.
The Microsoft Kinect. So how many of you have played with a Kinect before? So about half of you. So obviously this is a Kinect 1, so it's a little bit out of date. And since you've probably seen this before on the gaming, it's interesting to note that a lot of research groups are using this in human-computer interfaces for robotic applications. You just need to go on to YouTube and search for applications of the Kinect, and you'll find a whole array of hobbyists who basically have taken this Kinect and they do things with it. And that's because if you can get hold of one of these on its own, okay, they're not cheap. Well, actually, Kinect 1 might be cheap now. Now there's Kinect 2, I don't know. I mean, they were about £100 when I bought them. But you can go onto the Microsoft website, and I'm just going to show you directly what's off Microsoft website. And there's a Kinect SDK software development kit. So you can download this free of charge, plug the Kinect into the computer. Just make sure you don't have any other webcams connected, because that can cause problems. And you can run the demos. So at the start, just before I started, I did run a demo. This is a basic audio demo. So if you've used the Kinect, you know that you can put it in your living room, and you can stand 3 meters away, and you can go Kinect Play, or Xbox Play, whatever you say. And it does quite good speech recognition at a distance. Speech recognition at a distance is hard. We're all used to having Siri on the phone, so you're probably speaking to your phone. Just go and try it in a noisy pub and put the phone about 1.5 meters away and see how well it works. Doesn't work at all, right? Okay, so to try and inspire you, I think as more and more people use speech recognition on their phone, user demands go up. And users will expect in very shortly to be able to use Siri anywhere at any time, including in a pub. Okay, at the moment you kind of go, it's early technology, I can't use it when I'm in Cloisters on a Friday night, but I'll let it go. But I reckon 10 years, as technology improves, the expectation will be I can just use my phone as speech recognition whenever. We're not there yet at developing the techniques that can do distant speech recognition reliably in that kind of noisy environment. There are several thousand researchers around the world, people at Google, people at Microsoft, who are trying to develop these techniques. And if you go into, for example, that particular area, that's what you'll be developing over the next 10 years. So you're sort of learning how the basics at the moment, but sort of think that in 10 years' time, you'll be making some of these applications work. So the Kinect, one way of sort of dealing with speech recognition at a distance is not to have a single microphone like your phone does, but to have an array of microphones. So this device actually has 4 microphones, which are spaced, well, sort of, I don't know, 5 centimeters apart. And by using the fact that you've got multiple measurements of the same signal, but arriving at each microphone at a slightly different time, then you can work out, first of all, which direction the sound is coming from. So if I come around here and try it. So remember, if I speak at this angle, because that's in this plane here, when I speak to the Kinect, it's going to hit this microphone first before it hits that microphone. That time difference of arrival, as we call it, is enough to try and work out that I've come from this direction, as opposed to, say, from a direction over there. So I'm at quite a wide angle, so if I move over here, hopefully that arrow will sort of follow me, and as I come around, it will sort of, it knows where I'm coming from. As soon as you know where someone is standing within the room, then to try and do distant speech recognition becomes a lot easier, because you can basically ignore all sounds that come from a different direction. So that's one technique which is going to become useful. So I'm surprised actually already that something like the Samsung Note 4 and the iPhone 6, if they're getting sufficiently big, there's no reason that shouldn't have an array of microphones down each side. And I reckon by the time you get to the Note 8, it will have an array of microphones. Okay, because these things are coming out once every year or so. So you've got all sorts of demos. The other nice thing about the Kinect, and you can go and have a play with this, is the Skeletal Tracker. So, yeah, that's me. Okay. Right, okay. So what this is doing is actually got a depth sensor. So it's able to work out that I'm in a particular plane, because I'm approximately one-dimensional, or two-dimensional, from the perspective of a plane. And right, you can't see my legs, but it's just the angle. I need to be sort of, a couple of rows back. Anyway, the skeletal tracker, what it's going now, it's coming up with basically a point cloud. I don't know if you can see, depends what angle you're at. There's an infrared beam here, and that infrared beam is getting sort of basically reflected, and it's able to estimate my depth. And it can do things like background subtraction. It can sort of remove what's going on in the background. Yeah, I mean, you've seen that before. If you can get hold of a Kinect, I always think it could be a nice lab demo on this sometime, but who knows? Yeah, that's okay. Okay, so it's pointing at you too. Good. Right, the one thing I'd say about the Skeletal Tracker, this has got, I think, got a GPU inside. So Kinect itself is doing a lot of analysis. And it's interesting that the person who did this, who wrote the Skeletal Tracker, so bear in mind that this device has a lot of electronics inside, a lot of development. But the Skeletal Tracker was a result of the output of a PhD of a student from about 2009, 2010. So the Kinect and for the Xbox came out 3 or 4 years ago. And a year before that, someone did a PhD. It was at Cambridge University, and basically they went to work as opposed to, they got absorbed, Microsoft knew about this because of Microsoft research down in Cambridge, and the work of that PhD was quickly absorbed, quickly implemented on this device, and now this is a multi-billion-pound product, right? That could be you, because the output of a PhD is when the guy was probably 25, and I don't know what you are, 20, 21, I don't know, 4 years' time. So imagine just what you can do. So the other thing that is a very simple application, which I thought I'll show you. Okay, right. I mean, obviously, this is a really bad implementation. You're obviously used to, that's a shame. Yeah, okay. You're obviously used to sort of seeing this in the special effects industry, but this is incredibly simple software. So if I stand here, it will know in a moment, so I hope. It should work out that I'm not part of a background, because it's measured a background, and as soon as I come into it, it'll go, okay, oop. Okay, there I am. Okay, yeah, so you can sort of, you can go and have a play with this. So that is it. Okay, this is image processing. So image processing is sort of two-dimensional signal processing. Okay, so that's enough of that. Right, what I'm trying to say, as I said at the start of this lecture, this is supposed to be a sales pitch. I'm going to try my hardest to convince you this is not software. This is not software. I mean, it is software because it's implemented in software. But it's an algorithm. How does that algorithm work? So the background subtraction is easy, because all you do is that you simply take an image of a background, you average that over time, and then when someone new comes into the scene, you can subtract the background. That gives you, now, mean minus the background gives you something weird, but at least you know what's in the background and what's in the foreground. You can draw a mask around the image that you've actually got, and just sort of, just like you do in Photoshop, just subtract the background, overlay that on the background again. That's how it works. Yeah. Now, your question is that signal processing? Well, at a basic level, you could think, well, yeah, I could do that just by hacking a bit of code. It is signal processing. If you want to do it accurately, you need some additional techniques, because as you saw on the demo, it wasn't very good. The boundary between the foreground and the background was terrible. There's a lot of improvement you can do on that.
This production is copyright the University of Edinburgh.